Here's something I commonly do when I run into difficulty. I go back to basics. So, I am starting over with a linear version of the Halbach Array. And the beginnings of a track. Okay, and here it is with a longer configuration. And obviously, it's not producing results. Now we'll flip it around here. And I'm guessing we get the exact same results. Just for fun, I'm going to show what this cart does with this track here. These are north out, and the smaller magnets are north facing forward. These are south out, south facing forward. You start it out at the opening, pulls it in, drags it back to the beginning. Go from the other side, get it in the field, pulls it in, draws it back about to the center. Flip this the other way. Once you get to the end, it wants to kick it right out. It doesn't do much in the middle. You get to the end on the other side, same thing. Well, it doesn't really do anything, but it's interesting at least. Just for fun, sometimes I like to look at some of the different designs that people got out there. This is something I pulled up on a Google search on the Halbach Array. No idea who put it together, or it could be anybody. But it's close enough to what I was playing around with anyway that I thought it might be fun to just give it a whirl. I wasn't really expecting it to work, but it's fun to play around with this stuff. And obviously it works until it gets to the Halbach Array part. The repulsion force is just too strong to get through there, as I suspected it would be. If you manage to get to the end, it really does null out, and eventually even pushes it away a little bit. So, whoever put it together was on the right track. It just doesn't get past that repulsive force there in the center. Works a little better backwards, though. He built an assembly here and drew it in this way. With a little momentum, you could kick it through. Here's a video that was posted recently to Sons of Tesla. It's an alternative energy website, which I'm a member of. This design here, usually I won't even waste the time to explain this, but I've been doing this long enough I can pretty much look at a design like this and tell you there's just no way. It just won't work. But in this case, it really only will take me a few minutes to throw together something and show you why this doesn't work. If you look closely, though, there is a huge fundamental flaw in the design. Some of you may catch this right off the bat, and some of you may not. But I'll just throw something together real quick and show you what it is. Okay, here is a quick example of this design actually put together. The bearing I have it on, it rotates pretty easily here. I'm not going to bother to put together a stator assembly or anything. I just put a few magnets on here that are put together in the arrangement shown in that short video. You may get right away exactly why this doesn't work. If you look closely, the magnets on the stator assembly are in exact opposite of the magnets on the rotor, meaning it sticks. Alright, so if you place this between two of these, it will draw it to the next one, but then it wants to stop there. And that's what I meant by a huge design flaw. Now, if you wanted to sit here and bounce it up and down and throw a little mechanical movement in there, yeah, you could produce rotation, but that's obviously not what any of us are going for. So, that's why simple designs like this just will not work. And I wish they would, and it would be wonderful, but it's not quite that simple.